Ho, what's up everyone? We are back again with another problem, and today we need to sort out if we need to find out if a binary tree contains a pseudo palindromic path or not. So what is a palindromic path? We need to traverse a binary tree from its root to its leaf, and in that process we need to store all these numbers, and we need to check if these numbers form a palindrome or not. So in this example, 233 and 211, both of them are palindrome. If you don't know what palindrome is, it is if if you are given a binary tree from digit, because I at least one of the permutation of, okay, I was wrong. So what palindrome, we need to find what's if it has pseudo palindromic numbers or not, and I was thinking it is a palindrome, but okay. So firstly I'll explain what a palindrome is. A palindrome is where its first and last number is same, second and second last is the same, and so on till if it's a odd number, like the length of that array is odd, then only one element remain in the middle. If it's even, then both of the numbers, so n, if the length is 1, so n, if the length is even, so n minus n by 2 and n by 2 plus 1 should be equal. It's that is called a palindrome. And what a pseudo palindrome is, a pseudo palindrome is if there exists a permutation of these number such that we can form a palindrome out of this. So for in this example, 233, we can arrange them as 323, so it's a palindrome. 3 3 are equal, there's a 2 in between, it's okay. Also here we can do this, but here we can't do this. 2 1 3 1, we can't do this, the same thing. So what we are asked to do here is we need to calculate how many pseudo palindromic paths exist in this binary tree. So the approach is simple. We'll start with root. We'll traverse to each leaf, so I'll traverse to 2 3 3, then I'll go to 2 3 1, then I'll go to 2 1 1, and I'll store them in an stack, and then I'll check if it is a pseudo palindrome or not. So how do we check if it's a pseudo palindrome or not? See, if a number is palindromic, it has only two possibilities: either the frequency of all the digits are even. So in this example, not in this example, in some other example, let's say 4 2 2 4, so the frequency of 2 as well as 4 both are even, they exist twice, so each 4 needs another 4 in this. But if it's odd frequency, if it's an odd number, so like there only exists 3 digits, then what we observe here is that the frequency of all the numbers is even except for one. So at most only one odd frequency is allowed. In this example, 2 3 2 3, so 3 has a pair but 2 does not. 2 stands alone and it is perfectly valid, it is a palindrome in that way also. So we can turn around the number and it will still be the same. So the key is to store them in a stack and check if they are the frequency of these numbers are same or not. I tried doing this, I failed badly, and I'll let you know why. Because there are at most 10 to the power 5 nodes, and there's also a hint given to you that the values are from 1 to 9. 0 is not included, remember, and from 1 to 9. We can take this as a hint. So what we now need to do is we need to traverse first. So there are, this is called depth first search. So there are only few ways, there are, I mean, three ways to traverse: in order, pre-order, post-order. So if I would remind you, how would you search, how would you go to 2 3 3 while printing them? What order would that be? I mean, you could reverse also. You could like take 3 3 2. It's the same thing. How would you do that? So this can be easily done with pre-order. So it is left, then print the node, then print right. Uh, so it can be done in like pre-order way. And so sorry, I just explained pre-order as in wrong way. So what pre-order is? Pre-order is root, then left, then right. First it will print the root, then it would go to the left, and then it would like that it would continue, and it will again print the root, then it would again go to the left and then print the root, and if it is empty then it would go to the right. So that is pre-order, and what I explained before this is in order traversal. Please, I'm so sorry about that. Again, like, let me take a step back, explain you what we are going to do here is, even though this would be a long video, I'm thinking, because I haven't even gone to the code part yet. Now what we'll do is we'll traverse it in pre-order. So I'll store 2 3 1 3, and then I'll check if this is the leaf node. As soon as I hit the leaf node, I have to check if it's a palindrome or not. If it is a palindrome, I'll take a counter and I'll increment the counter. Then before I'll do this before inserting the 1, then I'll remove this 3 and then I'll insert the 1. Now how will I do this efficiently with 1 to 9 number is using bitwise operations here. So instead of taking a stack, what we can do is we can take a number, a binary number. So it has 0 0 0 and all. Let me quickly show you what I mean. So uh, it is not visible right now. Yeah, it's visible. Now what I want to do here is I'll take a number which is 0 0 0, and I'll only count the 9 digit. So if I left shift it by 1, what that mean is at its first index at let's call this an index right now. So here it would become 1. So now I know, sorry, yeah, now I know that if this has become 1, there exists 1 only once. Again, if another one arrives, then what happens? If So before doing that, what I do is I okay, let's just before doing this, what I do is I take the previous number which I already had, which was 0, and I XOR it with itself. So what happens is this and this, since the both of the digits are different, this will remain 1. Rest all will be switched if they are same. So if they are same, they will be 0. If they are not, they won't be. Now again, what if another one arrives? Then I have to right shift it again. So it would be 0 0 1. There's another 0 and there's another 0. Okay, and if I XOR it with my previous element, what I will have is a 0. And my PC is hanging way too much right now, I don't know. So the key here is you first need to keep a let's call it a number which is 0. You need to right shift it with the number you have found at the value, then you need to XOR it with its previous value. So what happens is, if you XOR, no, you take 1 and right shift it that number of time and you XOR it with its previous value, and then that would be your stack. That would be like a frequency stack. So how many time has this number occurred? So if it occurs 1 time, it would be active. If it occurs 2 time, it would be off, and it occurs 3 time, odd number of time it would be 1, even number of time it would be off. Let's move ahead. We have done that. Now we have hit a leaf node. Now we need to check if all the frequencies here are at most 1 odd and all of them are even. How we would do that is we would check if its and the previous number to it is equal to 0. So again, I need to take an example. If let's consider an example of 3. So 3 is 0. Let's consider an example of 5. So 5 is 1 0 1, and what 4 is 4. I'm so sorry, this is not 5, this is 3, this is 5. What 4 is 1 0 0 0, and we need to AND them. So if we AND both of them, what the result would be, 1 and 0 would be 0, this would be 0, this would be 0, and this would be 1. Since this is not 0 right now, and why is it not 0? Because at two of the digits, that is 1 and 4, with odd number of times in this. So let's take another example. If we have a number called this, so it's basically, is it a power of 2 or not? If we have this number and then we take XOR of this with what is this? This is nothing but 4. So if we take an XOR of this, with its previous number, which is 3. So and not XOR, and if we do an AND with this, so my answer would be 0. So this is a way to find if that number is a power of 2 or not. And if it is a power of 2, it is definitely for sure confirmed that there are at most one active bit in the whole number, because what binary number is 1 2 3, I mean 2 raised to the power 0 to 1 2 and 3. So it is 2 raised to the power 0 is 1, this is 2, this is 4, and this is 8. So if only one bit is active except for this last bit, which we are not counting, then we can for sure know that this is a, even if this is active, then we can wait, okay, where my cursor is right now, I can't see my cursor, I'm so sorry. Yeah, so if even this bit is active, we know that it is a 2 raised to the power something. So but the key here is that only at most one bit should be active, not more than one, because if you add 8 and 2, I mean if this and this bit are active, then it would be 10, which is not a power of 2, and then we would know that there exists a number which exists, or the frequency of that digit is odd in this. Okay, enough with the explanation. Now I'm going to type some code here. While explaining you, what I am doing is, here I've already done this question and I'll be recapping what I did, and I might make some mistake, then I have to maybe look at the code again. First we need a count, as we know, not cout, count. Then what we need a path. What I'm calling the path because the solution called it the path, but you can call it anything. The path is just uh, like the stack, the frequency stack. Call it the frequency of each number from 0 to 1, a frequency array, as we could say. Now what I'm going to do next is, for what I'm going to do first is I'm returning a count again. Why is okay, I'm so sorry, it should be intended, my indentation was wrong. Okay, now what I need to do in between is, first I need to traverse. For traversing I have two ways. Either I could use a recursive way, or I could use a stack. So I'm using a stack. So first let me make a stack, and that stack would contain two things. The first is it would contain a pair of two things. The first is a tree node, and then the next value is an integer, which will be our path. So we need to know that what the previous number hold for us, and we would name it as st. It works, and it would be new stack. That's it. Let's move on. Now what we want to do is, let's insert something into this. So I want st dot push. What I want to push here is, I need an I need to create a pair. The pair of what? The pair of my root with my with a number 0, because that would be my starting pair. Now while my stack is not empty, I'll start while my st is not empty. Done. What I want to, hey, done. Now what I want to do in here is, I want to check if my root, the node that I have, is null or not. So I need to first retrieve it from the stack. So I'll make a pair first. So this pair would be, let's call it p. A pair of tree root and integer is what I require here. Done. And let's call it p for pair, for easy naming. It would be new pair. And wait, why a new pair? Let's just pop our element straight from it, and it would be done. Okay, now I have a pair. For that pair I need a tree node as well as an integer. So first I create a tree node, then I'll create a integer. I'll call the integer as I have that integer, I'm so sorry, I created it above. I have that integer, but I need the tree node, so I would be calling it node. And then I would use p dot get key for my for the node part I would get the key, and for the int part I would get the value. So it would be p dot get value. Okay, we are done. Now what I want to do is I want to check if my node is empty or not. If it is empty, I have no business with it. But if it's not empty, what I need to do is I need to calculate the path. So the path would be equal to the path XORing with 1 left shift how many times? Node dot well times. I hope it's well. Yeah, it is well. Now what I want to do now again is I want to check if my node is a leaf node or not. So how would that be if root is root dot leaf equals to null, as well as node dot right also should also be null. Then I know for definitely then I'm definitely sure that it is my leaf node because it has no children. Now if it's a leaf node, I need to calculate if I need to increment my counter or not. So when will I increment my counter? If path and with path -1 equals to 0. Okay, the first things first, I need to properly prioritize my expressions. So first the path would be one would be subtracted from the path, then path and path -1 would be and against each other, and then we would compare if it's 0 or not. If it is 0, we need to increment our count, else we need to do nothing. Now if it's we are right now here, so if it's left and right are not null, what we want to do here is we want to insert the right and the left node now. So we can insert them in any order. I'll insert the right first and then the left. So what I'll do is I have a stack called st. I'll push something to it, and what I'll push is a new pair, and what that pair might contain, that pair would contain my node dot left right, sorry, I'll first insert the right, comma, path which I've created. Again I need to do that again, and I'll insert a left here, left, left. All done. It would call itself recursively until it's done. And let me see, there's a compilation error because I missed a bracket there. Done. Okay, and it works. And let me see if I have made any silly mistakes there, otherwise it would be accepted like it is. And I hope you guys understood. If you want to really understand this solution, what I would suggest you to do is visit the solution page for this. It's a bit slow, I don't know why, but you must really visit this solution page, and it has some great detailed explanation let me move out of the frame there. It has some great detailed explanation, step by step explanation of each and everything, of why what is happening and how what is happening. Even if you don't know in order traversal or pre-order traversal, it would show you pre-order traversal, it would show you in order and post-order traversal. And this is it, guys. If you would read the discussion or the comments, you would find an easier way to do it, and some proper things too. And that was it for this video, guys. Thank you so much for sticking with me.